Assalamu alaikum. Welcome to World Geography with M.Adnan. So today's tutorial is related to how can we make the LST of Landsat 8 and 9. So let's be started. As you can see, our data is here of Landsat 9 and date of 2 October 2023. So first of all, we need a formula for it. This is the two-step based formula for Landsat 8 and 9 also because these both are for same Landsat. So now we select here this formula. Let me zoom in. Okay, so because this is very blur, so I hope so try to define it. Here is the main basic formula is this, in which we use the band 10, as I am open already band 10. Here you can see band 10, this one. So we go simple to the raster calculator. Here I search for the raster calculator on a search tool of Arcgis. Wait a minute, this spelling is not good. Again mistake calculator. Okay, sorry for this. Raster calculator, we here select raster calculator, and first of all we apply the formula. For here we need some basic values for it, which have constant values for all the data of Landsat. It depends on the Landsat. Landsat 7, 5 have different values, and Landsat 8 and 9 have same values. So now we're going to select the text file of it. I'm open my file where I keep it. The text file of it is will be showing here with the name of text. This one, MTL. Okay, this MTL file we should open here, and now we're going to make our formula. Here you can consider we use these values, and these values will be defined as ML multiplicating band radians. Okay, radians multiplicate, or AL means radians 8 band, and O means correction value of band 10 is 0.29. Okay, this is the constant value. These are the constant value. Just this value will be changed, which is called the DN value or the raster value. Okay, so I'm back to my software again. Now I keep here these constant values and showing you to in this file radians multiple value for the band 10 is will be radians multiple. Yes, here will be this the radians and band, and this the radians multiple value, which is represent here. Okay, radians and band and radians multiple value. It's maybe a reflective. Wait a minute, I need to check here what was that. It's 0 point something like that. So radians multiple value, this one value will be used, radians multiple band value, and exponential means 3 times ago this to the left side of point. Okay, so we use this value, this one 3 times to the 3. So we need to copy this value, and here we go, 0.003342. like this will be this one value. Okay, so after that, okay, and we give it here static. So for the static, next we go to our formula back, and it will be multiplied to this, and again to multiply, one time multiply. No, this time not multiply, this time will be add this value, and it have 4 zeros with a 1 with a point, and this will be added to the band 10, and then subtract with this value. How much zero? 4 zeros. That's, I need to addition 0. 10 this will be the 4 zeros. Okay, 4 zeros done, then minus 0.29. Here minus means subtract 29. Okay, so we give is geodatabase location. For I going to the folder where I need to save it, the presentation here. Yes, here I give the radians, it's named to as radians 2023, simple 23 I write. Okay, and spelling little bit, save it. Okay, it will take time, so I escape it. So as you can see, our raster is done. Now we're going for the next step. This will be 2 steps, but we will be divided it into 3 steps, because we first find it into the Kelvin, then we subtract this value in the next step, and then we got the elastic temperature in degree. So now we have some constant values like K2 and K1. This is the constant value for this band, and which this formula we will be applying now. Again we're going to the raster calculator. Open the raster calculator. Now here K2 values for this band should be like this. Where is K2? Where is K2? This one. This value we will be copy from here. Control C, and we're going to here paste, and with the divided, and then we select the ln formula from here, and then we again go back to what formula which we need. Then K1 divided by lambda, L lambda, and then plus 1. Here L lambda means the radians is divided. Okay, is divided by the K2 values, which I need to copy from here, the K1 value. Sorry, the K1 value, this one. No, this for the band 11 we need this one, because we use band 10. Now we're going to Arcgis, which is here, and we keep it here, and simple here plus with 1, and we give this to the name. Now its name will be Kelvin, because this will be in a Kelvin degree. So okay, now little I escape it. So as you can see, we get Kelvin in the Kelvin values. Now we subtract it 273 as I'm showing the formula. This one will be, as I said, we convert it into the step 3. Now we second apply for raster calculator, and just separate the 273 value from this 273, and we just give its output as degree with a 2022. Okay, now we going here, just simple select, and we will be get our values in degree centigrade. And let us skip the video. So viewers, as you can see, our temperature will be get in the degree centigrade. The highest temperature of this region is 38, while the lowest temperature will be the -1. So because this is of the October, and in this region will be in the northern part of that area, and here will be the clouds, sorry, and here will be the glaciers. So and cold area this. So that's why in the October there will be the temperature going to the -1. Now I just change the color line from here to showing its which area have more values for this. So the mostly the center part is have a high temperature, while some region have lowest temperature, and I classify it. I need it in the stretch value. So I hope this tutorial will help you in your estimating the Landsat temperature, and as you can see we apply it on the Landsat 9. Okay, on the Landsat 9 data and the formula which we have of the Landsat 8. So it's mean the Landsat N and the Landsat 9 have same formula and same values. Okay, so for more informative videos you need to subscribe our channel and stay tuned with us. Thank you so much.